Friends, how are you? Welcome to my default of physics channel. So in this video, my topic today about equilibrium. Equilibrium in physics. What is user equilibrium in physics? So first of all, you will subscribe my channel and press the bell icon so now I am start to equilibrium topic. Equilibrium in physics, the condition of a system when neither its state of motion nor its internal energy state tends to change with time. A simple mechanical body is said to be a equilibrium if it experiences neither linear acceleration nor angular acceleration. Useless unless it is disturbed by an outside force. It will continue in that condition indefinitely. For a single particle, equilibrium arises if the vector sum of all forces acting upon the particle is zero. A rigid body, by definition distinct from a particle, is having the property of tension, is considered to be in equilibrium if, in addition to the states lifted for the particle above, the vector sum of all torques acting on the body equals zero, so that if state of rational motion remains constant, and equilibrium is said to be stable if small oppose the displacement and return the body or particle to the equilibrium state. Surface and equilibrium is unstable if the left departure produces forces that tend to increase the displacement. An example is a ball bearing balanced on the edge of a roller blade. In thermodynamics, the concept of equilibrium is extended to include possible change in the internal state of system as characterized by temperature, pressure, density, and any other quantities needed to specify its state completely. At strict thermodynamic equilibrium, the temperature of the system is uniform, and any gradients in state functions such as pressure or density are balanced by external forces so that they remain constant. For example, the equilibrium pressure at the bottom of the column of air is higher than at the top because of the force of gravity, and density gradients in the centrifuge are balanced by the centrifugal force. It is also useful to consider quasi-equilibrium process where, for example, temperature gradients are allowed if the rate of heat flow is too slow to be significant at a big process, but the system is otherwise in local thermodynamic equilibrium. For example, the adiabatic expansion of a rising column of air amounts for the decrease of atmospheric temperature with attitude. Weak interaction. Fundamental force of nature that underlies some forms of radioactivity governs the decay of unstable subatomic particles such as mesons and integrates the nuclear fusion reaction that fuels the sun. The weak interaction acts upon left-handed fermions, i.e. elementary particles with half-integer values of intrinsic angular momentum or spin, and right-handed anti-fermions particles interact through the weak interaction by exchanging force carrier particles known as the W and Z particles. These particles are heavy with masses about 100 times the mass of proton, and it is their heaviness that defines the externally short-range nature of the weak interaction, and the mix of weak interaction appear weak at the low energy associated with radioactivity. The effectiveness of a weak interaction is confined to a distance range of 10-17 meter, about 1% of the diameter of a typical atomic nucleus. In radioactive decay, the strength of the weak interaction is about 100,000 times less than the strength of the electromagnetic force. However, it is known that the weak interaction has intrinsically the same strength as the electromagnetic force, and these two apparently distinct forces are believed to be different magnifications of unified electroweak forces. Most subatomic particles are unstable and decay by the weak interaction, even if they cannot decay of electromagnetic force of a strong force. So friends, how is my topic about equilibrium? I will describe about equilibrium and some basic of equilibrium. If you like this topic, so subscribe my channel, press the bell icon so now you go to my another video. Allah Hafiz, we will meet next video. Allah Hafiz.